For the chapter 20, we will speak about the first law of thermodynamics. Look at the figure. It's a Joule's experiment that demonstrates the relationship between heat and mechanical work. So he made the chamber that have the pulley and mass, and also have the paddle here that you can rotate. And inside this, they put the water in the insulated chamber. Then when the mass moving, so that is a mechanical work, it will make the paddle inside rotate. This will create heated in the temperature, so that is the temperature change in water. So that's what he can observe. So from this experiment, he can conclude that the external work related to the work or heat that included in the system. So then he can make the general formula for the relation between internal energy change in the closed system equal to the net heat added to the system minus the work done by the system. So delta U is the internal energy change. Then if the delta U have a positive sign, it means the internal energy is increased. If it's negative sign, so it means the internal energy is decreasing. And for Q is a heat or the thermal energy exchange. Q positive side is for the heat go into the system from the environment, so it means the heat is added to the system. And for the Q have minus sign, it means the heat is go out from the system into the environment. And for the thermodynamic, in physics, we define the heat that work from the system point of view. So then, if work have a positive sign, it means the system work on the surrounding. So if the work have negative sign, it means the surrounding do some work on the system. So that we have to keep in mind. Work in physics is mean work done by the system. So look more detail. If we use some symbol for the work on, it mean work done by the surrounding on the system, and work by is mean work done by the system. So if we look for the system for the expansion process, we have the cylinder that can move. So the system make a force with equal to pressure times cross-section area. And this cylinder move at a distance dx. So then in this process, it means the pressure inside is change, and also the volume change from V1 to V2, and V2 is greater than V1. So this is an expansion process. From the work, definition of work, W equal to P F dx, or F is P times A dx. Then if we use A times dx, it will become dV, or the volume change. Then work can define as the pressure times the volume change dV. And then if we do the integral here, we have W equal to P V2 minus V1. From this process, we can see that work on or work done by the surrounding will be minus. But work by means work done by the system. So you can see the system expand. So the system do some work. Work by the system will have the positive side. For the completion process, the final state is here and the initial state is here. So the compression we increase the pressure inside and the volume is decreased. So we can conclude that in the opposite way, work on the system or work by surrounding to the system will have a positive side and work by the system will have a negative side. So that's all. Then we can make the first law of thermodynamics again clearly, that delta U equal to Q minus W, which W is related to work done by the system. In physics or chemistry, we have a system, at least 3 types of system. First is open system, second is closed system, and the third is isolated system. For the open system, the matter or particle or mass can come from the environment or surrounding into the system. So we can have mass or matter exchange between surrounding and system. And also heat or energy can enter into the system. For the second type of the system, that is closed system. For example, if you have a closed or sealed container, then the matter or particle cannot exchange, so it cannot enter the system or go out from the system. So you have no matter exchange, but heat still can enter into the system. So we still can have heat or energy exchange between the system. And the last one, the isolated system. So you have something like the insulate, seal the container. Then no matter can enter and also no heat exchange between surrounding and the system.